Now, coming to you live from the 6 Pre-Calculus Math 11. Dance, dance, dance. Today, section 7.4, drawing the reciprocals of functions. Alright, today's concept I think is fairly straightforward and accessible. We're going to start off simply with the graph of some function. Here I've got f of x graphed where f of x is 2x plus 4. You can consider a table of values, the points -4, 4, -3, -2, -2, 0, -1, 2, 0, 4, and 1, 6, all showing up nicely on this graph. Consider what would happen if we took each one of those points and kept the y values the same, but instead plotted the reciprocal of the y values. So instead of -4, -4, looking at -4, comma 1/4. And instead of -3, -2, looking at -3, comma -1/2. Instead of -1, 2, -1, comma 1/2, the reciprocals. And you can see all of them in the table of values here on the left. If you look at what's sort of happening in here, an interesting thing happens at -2. On the original, of course, we had -2, 0, but over here in the reciprocal, we're getting an undefined value since the reciprocal of 0 is undefined. Well, let's go ahead and get Desmos to fill in the gaps here and graph this for us. Here's what happens. We get this shape going on here, and there's a number of key things that we have to consider about what's happening as we look at this reciprocal. So a few key things that we can see happening here. An interesting point to me is right here, and another interesting one is right there, where both the original function and the reciprocal have a y value equal to 1 up here and equal to -1 down in the bottom. Of course, if you're drawing 1 over f of x, if f of x is equal to 1, then the reciprocal is also 1. And if f of x is -1, then the reciprocal is also -1. So these are important points. They are known as invariant points because they don't change. They're not varying. Everything else here is changing. Some other things to notice here. Where the original function was equal to 0, we have an undefined value. We actually have a restriction for this reciprocal because f of x, of course, when you do this reciprocal, must not be allowed to equal 0. And you can see that there isn't any point on the new function where x is -2 because that would cause f of x to equal 0. It's a restriction now for the reciprocal. And another thing you can notice, though, is that as that original function is getting closer to 0, what happens to the reciprocal? It's getting greater and greater. In fact, it goes off to infinity here on the positive side, and it goes down to -infinity here on the negative side as the y values are getting closer to 0 from the negative side. And of course the opposite is true on the original function. As it's going up greater towards infinity, what happens to those reciprocals? They get smaller and closer to 0, which makes sense. As this function gets larger, say when it's 10, the reciprocal is 1 over 10. When this function goes to a y value equal to 100, then somewhere down here you're going to have y equal to 1 over 100. So it's always getting closer to 0. The same is true over here on the negative side. As the original function goes down towards -infinity, you can see that the reciprocal is flattening out here towards 0. It's approaching 0. And this is some calculus language here to talk about a function approaching a certain value. There are two things here that Desmos has not done nicely, and so we're going to go back over to the app, and I'll add in a couple of things that I would like to see on the graph. So right there at that value of x equals -2, what we like to draw in is something that we call a vertical asymptote. And a vertical asymptote means that the function, as we approach this x value of -2, is going increasingly up towards infinity or down to -infinity as we approach -2 from the left-hand side. So asymptote literally means not touching, right? And you can see there that it's going to get closer and closer to x equals -2, but never actually touching it. Well, horizontally, we have the same thing. Going off to the right, the function is approaching 0 from the positive side. Going off to the left, the function is approaching 0 from the negative side. So we have also a horizontal asymptote of y equals 0. And anytime we do these reciprocals of functions, we're going to end up with some asymptotes showing up in the graphing of it. Okay? Let's look at just a list of these key characteristics then. So key points to remember. The zeros of y equals f of x become the restrictions for 1 over f of x. Invariant points occur when f of x is equal to plus or minus 1, since the reciprocal of 1 is 1. The third point is really important, but also kind of obvious. When f of x is greater than 0, in other words positive, then the reciprocal is positive. And of course, when f of x is negative, then the reciprocal is negative. Taking a reciprocal doesn't change things from positive to negative. As f of x is approaching infinity, we saw that 1 over f of x was approaching 0. Of course, as you approach positive infinity, the reciprocal will approach 0 from above, from the positive side, and as you approach negative infinity for f of x, the reciprocal will approach 0 from the negative side, from below. And then the fifth point here, as f of x approaches 0, then 1 over f of x approaches infinity. And that really actually ties in back to the original point. The zeros become the restrictions, and as you get closer to those restrictions, your reciprocal function will go to either infinity or negative infinity, depending on whether you're approaching 0 from above or below in the first place, whether you are talking about positive or negative f of x values in the first place. Okay, let's look at one more and then I'll leave you to it. So what if we had the graph of a parabola instead? So you can see the table of values I've created there. You can see all these points along the way. Back here where x is -8, the original function is up at 3.6. If we do the reciprocal of that, 1 over 3.6, that's maybe not the nicest value. But of course, you know that 1 over 4 would be 1/4, which would be down here somewhere, and 1 over 3 would be 1/3, which is also down around here somewhere. I mean, I think the reciprocal of that really will show up as being a point somewhere right about here. I'll try to draw it. There we go. And then this value here is slightly greater than 2, so its reciprocal is going to be slightly greater than 1/2. There we go. And then this value right here is 1, and the reciprocal of 1 simply is 1. Right here we've got 0. Hey, whenever I've got a 0, I know I'm going to be getting a vertical asymptote, so I'll just draw that in. Another value, of course, that's really important to me is where is the function equal to -1. That's right here. I actually key in on two things. I key in, first of all, on the 1s, plus or minus, and I key in on the zeros. Those are the most important things to me. I can see I have another 1 right over here, a -1. I can see I have a 0 right here at 4, which means vertical asymptote. And then I can see another 1 right here. As for the rest of it, I can either rely on my knowledge of the fact that as this function originally goes up to infinity, the reciprocal gets closer to 0. I can either do it that way, or I can continue to plot points. But since I know as this one goes up to infinity, my reciprocal is going to 0, I can draw this coming up out of 0 and hitting the 1 right there. So I've got this. Now, carrying on, as the original function is getting closer to 0, I want to have my reciprocal carrying on up to infinity. And again, think about that. Right here, we've got a value of 1/2. As the original function is 1/2, what's the reciprocal? 2. As the original function is 1/10, what's the reciprocal? 10, and carrying on like that. I can do the same thing to the right of this asymptote, come up out of negative infinity and hit the 1. Now I will be careful here that I can see there is a minimum value on this function of -2. It appears to be occurring right around here somewhere. The reciprocal of -2 is -1/2. So I know it comes up to a maximum value of -1/2 and seems to be doing it right about here. So I'm going to take on from here, let this curve up to that -1/2 value, and then come back down through the -1 and back down along the asymptote down to negative infinity. It's nice to put arrows on the ends of your lines and your curves. Then over here on the right hand side, as x is greater than 4, we've got it coming out of 0 going up towards 1. So our reciprocal will come down out of infinity, dropping to 1. It will hit that 1 value, and then the original function is going back up towards infinity, which means our reciprocal function is dropping down towards 0. You can see these vertical asymptotes here occurring at x equals -5 and at x equals 4. And of course we also have the horizontal asymptote of y equals 0. And that's about it. So the key things to look for: find the ones, find the zeros, draw in the curves appropriately. I'm not going to do a 2 for you. I think you can just get out your textbook and get to work. See you in class.